Hello, welcome to Crazy Math Productions. Today we're looking at writing linear equations in slope-intercept form. Now, slope-intercept form is something that was developed by a French gentleman by the name of René Descartes. M stands for the slope, which is the word monter in French, and B is Y-intercept, and I have no idea what that is in French. Never quite figured that part out. But general rule is that whoever in math discovers something gets to write the rules. So M is the French word for slope, B is the French word for y-intercept, and this aspect of analytic geometry was developed by him, so he gets to name it. Now, slope-intercept form is very, very handy. It's very useful in a variety of applications, and we're going to spend this second chapter. Last chapter, we were looking at actually graphing using the equation. Now we're going to have a variety of forms where we see the graphed form and we actually have to write the equation. So that's the focus of today's lesson. We're going to start that process. Now, I like to talk about murder mysteries. Sometimes when we talk about murder mysteries, you could think about the game Clue. It was Colonel Mustard with the candlestick. Okay, it's a very similar process. Usually we need, say, a motive, and we need a weapon and a murder investigation, right? So we're going to use the same kind of thing here. What we're going to do, I remember watching years ago, there was a little Garfield, I don't know if you remember Garfield the cat, little cartoon, and he was in France, and he was trying to be a detective, and he was trying to look for clues, but of course he was in France, so he said he was looking for clues. So we're going to look for clues. So the first clue is the slope. That's our first clue. The second one is the y-intercept. So the point is, in this whole chapter, this is our focus. If we can find the slope, find the y-intercept, we can simply plug them into this equation, and we'll be ready to go. Let's look at our first example. Write an equation for a line whose slope is 1/2 and whose y-intercept is -3. Well, again, we're going to use y equals mx plus b. If you forget this equation, you're going to have a very hard time with this chapter. We use this over and over and over again. Now again, we're going to look for clues. The first one is the slope. The second one is the y-intercept. Well, they tell us the slope. It's 1/2. They also happen to tell us a y-intercept. So this is actually very, very straightforward, very easy. Since they tell us the slope, I've got both clues, slope and the y-intercept. Since they tell us that, I have both clues, and I can plug it straight in. Y equals, slope is 1/2. Y-intercept is -3. Now you have an option. You could keep it as this double sign here, or you could say -3. It really doesn't matter. One of these two forms, and that's correct. That's it. Okay, again, looking for clues. First clue is the slope. This time I'll just write m, because that's the slope. Second one is the y-intercept. Write an equation for a line whose slope is -2. Ah, that's a clue right there. Whose y-intercept is 3/4. So y-intercept is 3/4. Okay, so again, we need y equals mx plus b. So we're going to plug into y equals mx plus b, our slope-intercept form. M is -2, and b is 3/4. So as soon as you have both clues, you can plug it straight into your slope-intercept form, and that's all at once. Write an equation. Did we write an equation? Yes, we did. Always good to check to make sure that you've answered the question. All right, now we're changing things up a little bit. Write an equation for each of the lines graphed below. Now, just because the form of the question changes doesn't mean that our process does. We're still looking for a clue. I'm going to find the slope. I'm going to find our y-intercept. Now, as I look at this line, first thing I want to do is to try to pick out some points. Now, I definitely need the y-intercept. Y-intercept, this is the y-axis. So I want to look and see where this line has crossed through that y-axis. Seems to have passed through at, let's see here, 0, -1, -2, right here. So right there, you notice I put a point here. This line has gone through at exactly -2. And what do you mean by exactly? Well, you see how this is a perfect grid intersection. There's a grid intersection. There's a grid intersection. Right here, right there. You can see perfect grid intersections. That's what I'm looking for. It's gone through at -2. Now, the y-intercept doesn't have to be an integer. It could be between. But when I'm trying to pick some points for the slope, it does need to be at a perfect grid intersection. It's going to help us in that process. Well, I won't say it has to, but it makes the process much easier. Now, there was a perfect grid intersection. Now, see, that doesn't go quite through at that intersection. It's a little below. Here it's a little above, a little below, below, above. I'm looking for a point where it intersects, and I see it right here. See, that goes through exactly, and that's what I want. Now, when I teach my classes, I will tell them that for the slope, to find the slope from a graphed line, we are going on a journey. So we're going to be going on a journey. We're going to go from this point to that point, or from this point to that point. It doesn't matter. But I do need to draw a box, a rectangle to be precise. So we have a rectangle. Now we're going to count the blocks. All right. Now, do I need to go over? Do I need to go up? Do I need to go over to the right? It doesn't matter, as long as the slope is the rise over the run. It won't matter. So I want to start from this one, and I'm going to head to the upper point, just because I chose to do that. Now I'm going to start from here, from the bottom one. I'm going to go up 1, 2, 3, 4. So that is, again, this is positive. This is the negative direction. So I went positive 4. Now, I am here. Now, I'm not in Star Trek. I can't teleport over here and come to the left. No, no, no. I've got to keep going and journey to, we're going on a journey. We're going to the other dot. So we're going to go to the right now. And that is 1, 2, 3, 4, 5, 6 blocks. And again, this is the positive direction. This is the negative direction. I'm going 1, 2, 3, 4, 5, 6 blocks. All right, well, which one do I have to do? Well, slope is the change in the vertical component divided by the change in the horizontal component. So which one did I go up and down? The 4. And it's a positive 4. Which one is the run, the change in the horizontal component? It's positive 6. As always, I have to reduce this fraction. So 4/6 would be 2/3. Now, we had to work a little bit for it, but we have found our other clue, which is 2/3. And again, cannot forget, what is our slope-intercept form? Y equals mx plus b. Again, if I had forgotten that, I would have no idea what to do with the slope and the intercept. Plug these in. Y equals 2/3 x plus y-intercept is 2. And that's my equation. Again, the overall concept, looking for 2 clues. I found the y-intercept by where it was going through the y-axis. Found my slope, rise, run, reduce, plug in. Okay, example 4. Again, looking for clues. Where are my clues? As Garfield likes to say, clue. All right, I've got the slope that I need. I need a y-intercept. Let's look at this line. Where I would probably start with a y-intercept. It's a little easier. Now, it looks like the y-intercept is at positive 2. So I'll go ahead and put a point there. It's at positive 2. And I also need to find another point that I could use. Looking for a perfect grid intersection. Now, looks like it goes through here. Also goes through somewhere down here. Tell you what, this looks perfect, so I'm going to use this one. Okay, so I've got my 2 points. My y-intercept is 2. I do need to find my slope. So we are going on a journey. We're going to draw a box. Let's see. Draw my box, and this time I want to start from the top dot. It doesn't matter, top point. So I'm going to start from the top point. This time I want to go down first. So let's go down. Now, down is a negative direction. Up is a positive direction. So I've gone down 2 blocks. That's -2. I also need to get to this other dot, this other point. So I'm going to go now to the right, this direction. And this is the positive direction. The left is negative, so I've gone +1 block. My slope is rise divided by the run. So I've risen -2. What do you mean risen -2? Well, I've gone down and gone to the right, so that's a +1. Now, I could leave it this way, but it's not really simplified, so I'm going to divide this through and get -2. So I have my other major clue, and I'm ready to plug it in. Y equals mx plus b, that's my slope-intercept form. Y in this case equals -2x plus 2. And that's it. Now on to a different form. What if they ask in the form of a word problem? Well, guess what? My process doesn't change. I'm still looking for clues. We have m equals and b equals. Slope, y-intercept. In terms of a word problem, m is going to be some sort of a rate, some sort of a change over time. It's going to be constantly changing. B is going to be more of a starting point of some kind, some place where you're starting. Well, let's read the question, and it's very important that we find what we're trying to do. City parking garage charges a flat rate of $3 for parking, 2 hours or less, and 50 cents per hour for each additional hour. Write a linear model that gives a total charge in terms of additional hours parked. Well, here's the thing. The question. Write a linear model. That's basically what we're trying to do. We need an equation here that gives a total charge in terms of the additional hours parked. Now, when we see this in terms of, that's going to key us off. That's going to trigger us to think, hey, they're telling me what the y and the x are. Now, what's in front of the in terms of is usually the y, because what's after the in terms of is the manipulated independent variable, and that's the x. If you're thinking in science, thinking about dry mix, the dependent respondent variable is the y, so that's what's in front of the in terms of. What's behind the in terms of is usually the manipulated independent. This is what you're messing with, and this has to depend on this, the x variable. So let's see. Total charge is going to be y. Additional hours parked will be x. Y equals mx plus b. By the way, do you have to use y and x? No. Total charge could be c, and additional hours could be a, or h, or q, or theta, or whatever you want. You get to choose. Now, city parking garage charges a flat rate of $3. Flat rate of $3. And that looks important. This $3 looks very important. Does it look like a rate change over time, or does it look like a starting point? I'm definitely going with the starting point because it starts the flat rate. If you go in the parking garage, you're paying $3. That's the starting point. So B is going to be 3 because it's my starting point. Now, there's also 50 cents per hour for each additional hour. See, this changes over time. So change over time, this rate, that is 50 cents per hour. and that's my slope. So I have one clue, two clue, these are my major clues, and I'm ready to go. Y equals 50 cents x plus b. That's my equation, and I'm ready to go. Just a few more here, and we're done. Okay, again, my clues. First we have m equals and b equals, slope and y-intercept. 6 2-foot-tall pine trees were planted during the school's observation of Earth Awareness Week in 1990. The trees have grown an average rate of 3/4 foot per year. Write a linear model. There's my question. That gives the height of the tree in terms of, that's also very important. So the height of the tree is going to be y. The number of years is going to be x. The y goes in front, x behind. All right, so remember, the m is going to be a rate, change in time. B is going to be a starting point. Let's see, 6 2-foot-tall pine trees. All right, so 2 feet tall were planted at the beginning in 1990. Now, does that sound like a rate, change in time, or a starting point? It's definitely a starting point. You start at 2 feet tall. Now, we also have this 3/4 of a foot. The trees have grown an average rate. There's a key word. Per is also a key word. Not always, but it gives you a general idea. These are both indicating that it's just changing over time, but it's a rate. So 3/4 is my slope. And now I plug it in. Remember that y equals mx plus b, so in this case, y equals 3/4 x plus 2. And I'm finished. Now I will say, and going back to the last question, sometimes it's nice to let the person know if they've asked in a question, to answer in a question. So we could go through and say, well, you know what, I'll tell you what, it says write a linear model, so the equation will do in this case. In this one, it says write a linear model, the equation will do as well. So we'll just stick with the equation. In example 7, though, a car salesman makes a base salary of $250 a week and a commission of 8% on the cost of each automobile he sells. Write a linear model, so that's the question, that's what he wants to do. Not really a question, more of a statement. Gives his salary in terms of, in terms of, that's always important. So what's before in terms of, that's his salary, that's Y. Total price of the cars, that's X. So my clues that I'm looking for, the first one is M equals, the second one is B equals. We can see, car salesman makes a base salary of $250 a week. Okay, now is that a rate or is that a starting point? Well, the interesting thing here is that it's both. He does make $250 each week. But you're talking about for each individual week, that's how much he's going to get. No matter what he does, he will make $250. So really, that's his starting point in this case. He makes $250 a week, bare minimum. If he just sits in a chair all day, he gets $250 a week. But he really doesn't want to do that because he has some incentive. 8% for the cost of each automobile he sells. Now, you can't put an 8 as for example, he sells 2 cars, he gets 8% of that. Depending on how many cars he sells, this is the rate at which he accumulates money. So that 8%, we're going to change to a decimal, 0.08. Move that decimal place twice to the left so we get 8/100ths. And I have both major clues. I just plug it in. Y equals 8/100ths x plus 250. Again, I'd encourage you, if you are trying to get some practice on this, please go through, rewind the video, start Before I start, as soon as I start talking, go ahead and pause the video and try these problems on your own. See how you do. Then, if you don't get it right, rewind again, try it again. It's a good study strategy and something that would be well worth your time. Thank you so much, and have a good day.